In this video I want to talk about special triangles. So basically we have two special triangles. One of them is a triangle like this. It's called right triangle because this angle is 90 degrees. We call it a right triangle. And the two angles here are 45 degrees and 45 degrees. As we know, all triangles, the summation of all three angles has to be equal to 180. And as you see here, we have 45 plus 45 plus 90 degrees. It has to be 180 degrees. So I call this one A, I call this one B, and this side I call it C. We know A squared plus B squared equals to C squared for this right triangle. So A squared plus B squared has to be equal to C squared. And from sine law, we can say that this angle A, this one is B, and this one is C. We can say that sine A divided by the opposite side has to be equal to sine B divided by this length here. So sine A, the sine of 45 over A has to be equal to sine of B divided by B, this length here. And before I forget, you know, 45 degrees is the same as pi over 4 in radian. And 90 degrees is the same as pi over 2. So instead of 45 degrees, you can write pi over 4 as well. So, since we have two equal degrees, we can say sine 45 sine A has to be equal to sine B. So these two are equal. So we can conclude that from 1 and 2 that A and B are equal. So again, if I want to review it, if we have two equal angles for the right triangle, these two sides has to be equal to each other. So A equals to B, and it can be equals to 1 if we want. We consider it as 1. So in order to find C, we can say C squared equals to 1 squared plus 1 squared equals to 1 plus 1 equals to 2. So C is root 2. So this one is 1, this one is 1, this one has to be root 2. Now let's find sine of, I'm going to write it here, sine of 45 degrees, sine of pi over 4 equals to opposite divided by hypotenuse, 1 over root 2. We know the definition of sine is opposite. Sine of A is opposite, which is A or 1 divided by the hypotenuse. So 1 over root 2. What about the cosine? Cosine 45 or cosine pi over 4 will be equal to, for this one, 1 over root 2. Adjacent divided by hypotenuse. It's going to be 1 over root 2. The proper way of having this fraction is to somehow get rid of the radical in the denominator. We call it rationalization. In order to rationalize a fraction like that, we need to multiply both numerator and denominator by the same value. So it will be 1 times root 2 divided by root 2 times root 2. So it will be 1 times root 2 is root 2 root 2 times root 2 is root 4, or it will be equal to 2. So we can say sine of 45 or sine of pi over 4 will be equal to root 2 divided by 2, or cosine 45 equals to cosine pi over 4 equals to root 2 divided by 2. Let's find other trig functions. Tan of 45 or tan pi over 4 will be sine 45 divided by cosine 45, which is root 2 divided by 2 divided by root 2 divided by 2. Any number divided by itself will be equal to 1. What about cotan? Cotan will be the same, because cotan is cosine divided by sine, or the inverse of tan. So it will be equal to 1. And the other two, we have secant 45 or secant pi over 4 is the inverse of sine. So we have root 2 divided by 1, or root 2. Cosecant 45 or cosecant pi over 4 will be equal to root 2 divided by 1, and it's going to be root 2 as well. So all these numbers belong to one of the special triangles. So whenever we have two 45 degrees angle, we can conclude that we have sine 45 equals to root 2 over 2, cosine 45 or cosine pi over 4 equals to root 2 over 2, and following we can find the tangent, cotangent, secant, and cosecant. So that's one of the special triangles. We have another one. In total we have two triangles. Let me write it in this side. We have another kind of special triangle. It's a little bit different. I'm going to call it A, B, and C. This one C, B, A. The angles here, we have 30 degrees, we have 60 degrees, and obviously this one is 90 degrees because that's the right triangle. So 30 degrees, 60 degrees, and 90 degrees. We know 30 degrees in grade 12 and in college or university is also called pi over 6. Pi over 6 for 30 degrees, and for 60 degrees we have pi over 3. So we know again a squared plus b squared equals to c squared. Now we can say if we have 1 here, 2 here, this has to be root 3. Basically you need to memorize this length here. 1, root 3, and the hypotenuse is 2. So the hypotenuse is 2. The smallest side is 1, and the other one, the third one, has to be root 3. So that happens when we have 30 degrees and 60 degrees. And obviously the side opposite to 60 degrees has to be bigger than the side opposite to 30 degrees based on the sine law. Alright, so we can also verify it using this. We can say 1 squared plus root 3 squared will be 1 plus 3 equals to 4. So c squared is 4. Then c will be equals to 2. That's what we see here. Alright, so we can say sine 30 degrees or sine pi over 6 will be equal to opposite divided by hypotenuse, 1 over 2.